veins of dike. This is gabbro. The black is gabbro. And the granite would have been here first, and the molten gabbro found a weakened area and worked its way up through the surface. But this is a dike, and if you look up where it goes up through the sides of the outcrop, it's pretty crumbly. It's leaving cavities or gorges, whatever you'd like to call them. Dikes are an intrusion that runs vertically towards the Earth's surface. They may not have ever reached the Earth's surface. And there's been uplift, rifting. This area, and part of what we're telling you today, we may repeat a little bit of it tomorrow, is an old rift zone. Most of us focus on the last 250 million years since the Pangea broke up into the northern and southern continents, into the continents that we have today. And we don't really focus on the previous 300 million or 400 million or 500 million years. And so about the time plants, seed-bearing plants were taking over, this was a rift zone. It was rifting apart. It was diverging. And molten material was making its way to the surface. And so 1-inch hole, there's a cluster of 4 right here that were taken right in the middle of the gabbro dike, probably to see what its composition, structure is. And then you will see holes drilled on the edges. Some holes are drilled on the granite side. That hot gabbro would be cooking or baking the cold granite, so this would be the baked zone. And some took samples here. There's a series of 5 core samples taken out, moving away from the gabbro just to see the extent of metamorphism, changing this, not the composition but the crystalline structure of the rock type. So theoretically, this would be one type of rock, this would be another type of rock, and this would be a third type of rock. And on the inside edge of the gabbro, on the gabbro side edge, I've seen one once. That would be the chilled zone, because the hot gabbro, the heat is going from hot to cold, so it's actually cooling off, so it's chilling, and so its structure might change as well. Oklahoma, Aulacogen, A-U-L-A-C-O-G-E-N, and that word just means aborted rift.
And this stuff just leaches up.
Yeah.
It oozes.
Oozes.
That water, the Cretaceous water, and tar, asphaltium move through that formation because it's porous.
The water lifts it up.
It floats on top. So you would have to surmise that it probably, in a wet season, gives off more petroleum than it would in a dry season.
So this never dries up? The water?
I've never seen it dry.
How do you know the degree?
Well, because the sandstone that comes out here is Cretaceous, and up in the edge of the Slick Hills, in that research I gave you on the Zodeltone Mountain, it also comes out in that formation. So they're able to connect them by content.
How long has this been sitting
What, 500 million years? How many years is this?
So there could be. I mean,
yeah.
No, I mean it's been. I know it's been.
Yeah.
How long has it actually been seeping out?
Well,
is there any way to
lay on top of that? The Garber sandstone is actually similar to Lake Cretaceous.
Yeah, this is at the
limestone. So I would say within the last 60 million years. You also have to consider water's been coming up here and been carrying out hydrocarbons. As the hydrocarbons ooze out and go down, you can see it's kind of out here. And I usually think this is on top of it.
Yeah, it's on top of the hill. It's the last this formation that's here.
As those hydrocarbons accumulate, it kills off the plant growth. As you get more rain and everything, of course, what's going to happen is going to cut that path down through there. And you can, you know, how long has it been here? Well, you figure how long it's going to take from where down to there to where it's at right now. And that's how long it's been here. It makes sense to me.
And we don't know what was up above this. Because it cooled slowly before and rose faster. The ground, but it cooled rapidly. It wasn't very far under the ground. Later on, there was a resurgence of volcanic activity, and it put volcanic rock called diabase into this gap right here. Because it cooled slower, it's more coarse, and it erodes faster. So you have differential weathering. That's one of the things that you're looking at here. What did you say this was?
Rhyolite.
Rhyolite. I have a handout for you. And it will talk about,
Here's the handout.
at one point in time there was a stream above this, a different, and this caused a type of erosion.
Show up here,
And it created this valley.